for reading it and reviewing that everything is understandable. We did what we could, but it still needs some reviewing. So what we should go. What were you proposing, Griff?
I was going to propose that we just look at the Kanban board, and I'll post the link right here and just move things around and check in to see if there's any questions. I'll post it in the Telegram actually, and see if there, if there's any updates on things that people want to talk about. This is just the moment to move things around. I added revise the narrative and put that in there and said that it's in progress. Ben, you said that you had a couple things, right?
Yeah. So I mean, we can jump straight in and all try and open up the app deployment that I set up with Zen. And I'll just give some background about just mainly for Nelson what we did and what we're testing. Yeah, so the Flask app is multi-threaded, and for each user request that comes in, we set up a session with a cookie that basically separates each user's data, so the images that they're being served, the network pickle files, things like that, so that multiple users can use the app at the same time. So we've set it up and it seems like it's going to work, but it would be good to test it with the 5 of us here and see. I'll post the link. I think Griff, you posted it in Telegram as well.
Yeah, and it looks like this is like issue number 1 even.
It is.
Actually not.
No?
Actually, issue number 1 is a little bit more difficult to tackle. It is part of the issue number 1, but we still need that queue.
Ah, okay.
Not so easy.
So this is issue number 25.
I don't know if we have an issue 25.
I think the queue was a work in progress in this ticket, but we decided not to do it. But we can discuss that. But yeah, I mean, this is just the user sessions for now then. Okay, so just let me know once everyone's got the link open.
It is a good step forward. I just commented that the issue is not completed. The cadCAD task queue is not done, and it's something that we will need to do at some point in time. So I will let the issue there.
Cool. Should we can discuss it sometime.
For that issue, I let a link that explains how to do something like that. It will be something like, we have a process that is cadCAD. Well, it's a Python cadCAD process that only does simulation, and it does simulations by one, and we have a queue that the Flask is filling, and when a simulation is done, then the Flask server gets that simulation.
Okay, and that's to stop long-running requests?
Well, it is because if we have 2 cadCAD simulations running at the same time, I think that there is some kind of problem.
So this is what the user sessions actually solves, and it seems to run correctly. I run about a few hundred simultaneous requests.
A few hundred?
Well, I mean, like, locally, but.
Yeah, that's cool.
With cadCAD.
Yeah, with
doing the run, with the part that is running cadCAD.
Yep.
And there is no no problem among.
Well, yeah, I made a few comments in the ticket, but there's no problems that I can see.
And this is ticket 1, right?
Yeah,
Yeah, I
it
think I made some comments in there.
I will check out with Sagram, because he was saying that cadCAD is not safe for multi-threading.
Well, the
So
proof is in the pudding, because
the
we can try it
cadCAD,
right now, right?
yeah, I mean, cadCAD underlying cadCAD is matplotlib, which is not thread safe, but it can run multi-threaded. It just depends if you, as long as you stop it from accessing the same files, it should be fine, as far as I know. We might have issues pop up in future if we do more complicated stuff, I'm not sure, but at the moment it seems to run multi-threaded fine, as long as you don't have it accessing the same files.
It doesn't write on the same files, or it doesn't access the same files?
Yeah, it doesn't access the same files.
So the multi-threading part is only a problem when it comes to accessing files?
That's what it seems like. And people, basically the consensus on like Stack Overflow is that matplotlib is not thread safe, but you can run it multi-threaded. You're just not guaranteed of like incredibly stable operation. It just depends what you're doing. And the biggest issue before sort of separating the sessions was obviously that the user sessions were accessing the same files.
But if we're
yeah, I mean,
using D3, then we don't really need matplotlib, do we?
You still, yeah, possibly. I'm not sure what cadCAD uses under the back.
At the moment, we are using matplotlibs, and the idea in the future is not to use them anymore.
Yeah.
To send the data through JSON and then in D3 make the graphs. So we don't need that multi-threading for matplotlib, but we need that multi-thread for cadCAD. Because if we have many simulations working at the same time, it will be difficult. Also, I think that it has sense to have a queue of cadCAD simulations, because you can do some kind of loader, because if there are 3 simulations that are working at the same time, or 30, I don't know, maybe there are 10 simulations working at the same time in the peak. If they are all working at the same time, it is, of course, it's going to be faster for all the people that is waiting.
Yeah,
I mean,
definitely, I mean, that's
I
something
don't
else
know.
I commented on was, yeah, server resources is obviously the other reason. So I've already got a sort of queue set up in like a work in progress locally. But yeah, maybe I think we can separate that into a separate ticket. This ticket kind of sort of transformed into a user sessions ticket. Yeah.
it's great.
Actually,
I was just reading your comment here, and it seems like you found a good solution, and we can even test it right now, right? We can all push get to the cadCAD simulation and have the live demo.
Demo gods.
The demo gods.
okay, if you want to go with that, I think that if we see that it works, there is no need for a queue, and it is even better because we don't have to do more code for that.
Yeah, I do think
And
you'll
if
need
we
a
see that
queue.
there are problems because of that thing, I know that Michael was saying that, well, there is always that worrying about having a multi-threaded cadCAD, two cadCAD simulations working at the same time. I have heard that from probably you, Griff. I don't know.
Yeah.
But it's okay. Yeah.
but it seems like he found a way around you identified where the multi-threaded was a
Yeah,
problem.
I'm also,
and you solved it.
I mean, I made these comments once again in the ticket, but the other thing that I've heard from the cadCAD team is that the problem is not necessarily running to cadCAD. Well, this is another problem that was mentioned at one stage, was that it's, you know, they want to be able to multi-thread the actual vector mathematics operations on the behind cadCAD, rather than to make that the individual simulations faster. And I don't know if that was maybe part of the discussion as well, but I definitely think we'll need a queue in future because of what you mentioned, this, you know, the server resources. We don't have a massive server to run 10 or 100, simultaneous user sessions.
If that is the case, I don't think that we need that queue.
Yeah.
I think that just to understand it better. From the cadCAD team, they say that the only problem is to have matplotlib in multi-thread. cadCAD can work. cadCAD itself can work on multi-thread.
That's my sort of outside opinion, not knowing what's going on in the back end, but it seems to work. Yeah.
As long as every user has a user session and every file they create is a new file.
Yeah. Okay. Let's go with that. Yeah. Actually, they are not going to create files. They are going to create outputs like in JSON that it's going to be sent back to the user. So at the end, it is not going to be a problem. They are not creating files.
Yeah.
Well,
I think either way, we'll still at least be able to use the user sessions for other things like progress caching and things like that. Yeah, cool.
Yeah, it definitely fits. I mean, we needed to identify our users anyway. But it sounds like we can go to that link and get to step 5, right? Then we all
so
at the same time.
Yeah, exactly. Step 5 is cadCAD, which is going to fail because Heroku has a 30-second timeout on requests. So without sending a request to go perform the cadCAD simulation and then sort of pinging for the response, it's going to fail. But that's only because it's running on a Roku.
I don't know. I mean, I've been on step 5 for the last few minutes and run with it. I've been pressing run 2-3 times and nothing has happened. So I don't know if I did something wrong or.
So three of the run buttons won't do anything because there's nothing on the back end. There's no, as far as I know.
Yeah.
I think the first 2 work and then the next 3 don't.
What I mean is that I did 2-3 times because nothing ever happened.
And then, but also for the simulation stage, it doesn't work because there's a 30-second timeout. Is that what you said?
Yeah, I'm also not getting any response. Let me check the logs. Maybe this is an issue that. Let's see.
We can use the Commons IPFS technology, which is the same code, but it's well, it misses the part of session. It is not session safe, but it still works if it's just one person that goes through it.
Oh,
so,
yeah, and we don't get to test this awesome stuff Ben did. That's not fun.
Well,
yeah, exactly.
Yeah, the requests are working on my side.
We can work with that. We can later on put the Ben's code in the server, so it is going to work faster and
cool.
And until then, I don't think that if we can set up some continuous delivery or something like that for a VM, I never do that. It should just pull the. I don't know. I was doing it manually. I can't continue doing it manually, and I don't know if there is some way in which it takes the last commit from GitHub.
Yeah, GitHub has some integrated CI/CD things, but I don't know what options they have to deploy to. What did you say your server is?
It is a virtual machine in OVH.
Okay, we could maybe set up something there. I don't know. Anyway, so basically on the simulation URL, steps 1, 4, 1 and 4 will return results. 2 and 3 don't have any logic behind them. Yeah, so if we can all go on and check step 1 at the same time.
Okay.
The most basic thing we can try at the moment.
We can merge it, right? We can merge it in master.
Yeah, I think so. It's running pretty smoothly on the Heroku instance now. But yeah, let's test it first.
Okay, so we all go to the homepage and just click next, or we all click run on step 1 at the same time.
Exactly.
Okay, so is everyone at step 1?
Yeah.
Sam, are you there?
Not yet.
I'm just gonna, before you do that, I just want to get the logs, the Heroku logs on my computer, just so I can watch it as it does it.
I'm in step 1.
Andrew, are you in on this?
Yeah, I'm in.
Okay, step 1 in on go. 3, 2, 1, go.
Wait, shit. What?
It's okay. Oh, it's definitely slow. Although I also moved the number of participants.
Okay.
I clicked too early.
Oh, you got in first.
Like 2-3 seconds before.
Check your console logs as well.
Okay. Oh, it popped up now.
Oh, there we go. Okay, so it's very slow. But Heroku, I mean, the free instances are very low resource. So
I also decided to make my participants like 90.
nice.
It worked for me like a few minutes before while you guys were talking, but now it's not working anymore.
Could be very slow. Let me check the logs again. No errors, at least it's not crashing again like it was earlier.
It's running now, it's running now.
It is very slow because of Heroku, but when we have it in the virtual machine, it will work well.
I have some sort of uncaught type error that's just like going wild.
Yeah.
Can you share your screen?
I moved it up to 120. Yeah, I'll share the screen.
Yeah, there's no errors on the backend logs, apart from some very
it
slow
is
requests.
Wow, it's interesting. It is because of the SVC that is not working well. Well, it is trying to create a lot of participants actually. Yeah.
Yeah, it's because I decided to up the participants.
Oh, wow.
I had one type of error.
Oh yeah, sometimes the results appears blank for me.
That's supposed to happen, or not supposed to happen, but it's because there's no cadCAD simulation behind steps 2 and 3. I think that might be the case for you.
Yeah, for 2 and 3, there's no.
I will try to reproduce your error graph. How many participants and proposals that did you do?
120 and 6 proposals.
No, 150, right?
120.
120, sorry.
Yeah, I also came across a few math-related division by zero errors and things that didn't seem to affect the results you were getting on the front end, but I think we can create a separate ticket for that.
Yes, those were in the original simulation.
Yeah. Cool. Maybe they're not. They're probably not important.
They don't seem to affect the results.
Yeah, it's probably edge cases and things.
Yes, I am having the same problem, Griff. I will check out that later. Well, this week I won't be able to be more active, but we can. It is a problem from the D3 graph of participants and proposals. Is Fabio here? No, right?
No.
I just stopped sharing.
Okay. I can check it out, or maybe we change that when we do a new version of this graph, we can check it out. I will take that into account. That when there are a lot of participants, the graph crashes. But it's not a problem from the server side, and I think that it's safe to merge the pull request.
Cool.
Nice.
Yeah, it's all green on the server logs. Yeah, so I think we can create separate issues for other things.
Okay. Are there okay, so that one's still a work in progress then.
What is a work in progress?
This the cache, the user session solution for multi-threading, which I think ends up being issue 25. Or it seems like it's being worked out of issue 1, or it's like part of issue 1.
Yeah, so basically the queue, I think, was like addressing 2 issues, one of which was solved by user sessions instead of a queue. So we can decide if we want to make a separate ticket. I think maybe what would be best is to close this ticket because it's got all the comments related to the implementation. I don't know. So what do you think, Sam?
Reading the issue 25, which is cadCAD user progress, it is already being. I don't know what you are referring with that, Griff. The status is in some way kept. So you go through all the steps and you get the information that you got before. Are you referring that if you close your web browser and then you go to the same page, it should show the same results that you got? I don't really get that issue.
Yeah, I think that was the intention when it was put up there, was that it's for a front end so that when someone goes to the page, you know, they might click a few, but maybe they get distracted and then they come back and it's like, oh yeah, okay, where I left off.
So for that most simple case, I think it would maybe work.
But if a user closes the screen, they should go back to the beginning, right?
But why? Why not start from where they left off?
I'm not sure. In YouTube, for example, people get when they left the video.
Yeah.
But it usually is not the way that. I mean, what you are proposing is something that is out there, and at the same time, it is something that may be weird for people who are they just forgot that they were there, and then it's like, what?
I also agree that
I think
having the thing like continue where the user left off. I mean, I think it adds unnecessary complexity to this thing at this point. And I mean, most people when they come in here, this is a totally new concept anyway. So um, they will they need to go through the whole thing again to just to really know what's going on. Otherwise, so basically, continuing from where you left off when you've most likely forgotten what you did before gives no value to anybody.
So just, yeah, I think complexity wise, it's 2 lines of code. We've already got the user sessions set up with cookies. So don't worry too much about complexity, rather just worry about UX.
Yeah, if it's a feature we want. I believe this was brought up in our React call that was with like Paco and the crew, the front end crew, and they talked about it. So
I think because there used to be 15, or how many steps do we have currently? Is it 15, more or less?
I think that
I think in that case, I think
there's going to be 6. There's going to be 6.
Okay, cool.
Things that they have to choose.
Well, we have
nice,
a state that it's stored in the. It is not stored in local storage, but it's the Redux state, and it can just be stored. It's, as you say, it's not so difficult to do. I still don't see if maybe in the user experience part, maybe we should indicate that you are halfway, not at the beginning. I'm not sure. And also we should, if Paco were here, it would be easier. But the thing is that we have changed a little bit the plans from last weeks. We are going to have less images and more text. So we have to rethink also a little bit how we are going to present that to the users. My idea was to, as we are going to have more text, we probably are going to scroll down a lot. And I think, and we are going to have text, image, well, text, image, text, image, text, kind of. Also, then a selector for parameters, then some graphs, then more text, more images, more text, more selectors. This is probably going to be the flow. This is what I wanted to discuss with you. As Paco was thinking it is like an image or selector and then a few text on the bottom of that. We may have to change that. So maybe we can have just one page that grows and grows and you have to go to doing scroll, and when you select something, new text is appearing below of the selector, and you go advancing the story by making those decisions. It may have sense. Instead of having those next and previous buttons, we have text that is appearing on the bottom of the page.
Yeah, it definitely sounds like a combo with Paco in the front end team. But it is worth noting that the narrative is changing a little bit, and there are going to be some really interesting integrations with illustrations, and we'll see if this is possible. It's more stuff for Paco, but it's kind of crazy, and it's worth like bringing up in this call, because it's like the idea is that we have an illustration, and then we will have a slider that will change the illustration such that like maybe it's like you got to pick how many people, and so if you choose 3 people, then there's 3 people on the screen, And if you choose 5 people, then it's 5. And as you move the slider, more people pop up or disappear. And it'll be like layers on an illustration.
This is going to be the most difficult one. More or less, all the illustrations, well, no, not all, but many illustrations are going to be integrated in what the selectors does. So, for example, when we are selecting the hatch tribute, we will be showing both reserve and the funding pool. And if you change the hatch, you see how the funding pool is going to be more full or less full in some way. And we can have also illustrations must serve as something that explains what is going on. So making them dynamic, it's a good resource for that. We can just do that. And that part of adding and removing participants that are illustrated, I think it's going to be the most difficult illustration, but it's going to be super cool to do. So,
Yeah.
and also the illustrator is wants to do that in that way.
The illustrator, Nyan's really excited about it.
Yes.
That's cool. Okay, so that's that. I mean, that's basically my point on the narrative that I just want to bring out, that there are some changes. We also took out vesting, and we took out the augmented bonding curve piece. So we probably need to go through and put that in there. Now, Andrew, though, we still need vesting and the augmented curve stuff in the cadCAD simulation. We just don't, we're just not going to, we'll just put in default values for it.
Yeah, definitely, I understand.
Yeah. So even though we're taking out of the user story, in the end, the system doesn't work without it. So it needs to, nothing works without vesting.
What we did with Griff is to choose 5 concepts that we want to have to expose clearly in the narrative. And I don't remember what are all the concepts, but I think they were commons. Do you have the list over there, Griff?
Yeah, it's, well, I remember it's like hatching, commons, radical exchange, and conviction voting, and there was one more, but it wasn't augmented bonding curve. We basically took out the idea of the augmented bonding curve, and we're saving it for the next leap.
Yeah, we are, because if we explain so much in the first level, it is going to be too much. And also we will not have anything for the second level. And we can, and in this way, we can have a second level that explains very well what a bonding curve is. We can choose better parameters to configure that.
Yeah, in the end, the big thing is just that we were going to lose people real quick if we went so deep on so many topics. So we just had to, Sem made a point and we just had to cut it down. So we did, and we are cutting it down. It still needs a little bit of work, but the first part is good. The illustrator is aligned, and really I feel like we need to talk a little bit with Paco and then go to the designer again, Max, and like see if he wants, I don't know, do you guys think we should get a full design mock-up again or not?
I think that we could, yeah.
I think that would be very interesting to see a mock-up of how the illustrator would illustrate the more abstract concepts. The slider with moving the people and the people increasing and stuff. That looks cool, but that concept does not need as much explanation as other abstract concepts. So it'd be cool to see how the illustrations would in hand.
Yeah, for the moment, we are focusing on the first illustrations that doesn't include those selectors. And I explained in CAD about the rest of the things. We are still thinking on them, but more or less it is what we want is to connect the concepts through the illustrations and have in some way some holographic stuff there, because another of the problems that we have is that we are talking about digital or virtual money, and it is very difficult to depict it. So probably what is virtual will be an holograph in the story, an holograph that comes out from cadCAD.
And
So, for example, the reserve is going to be depicted as a bank, that it's an holographic bank, for example. And we are still not there. We still have to think about those things. What we have clear are the illustrations at the very beginning. And regarding having new mockups from Max, I think that it will be much easier now because, well, we just need a text that grows down. It is like text image selector, text selector image.
Yeah, my comments
yeah,
on the previous Figma layouts was that, you know, there was a layout of 10 different pages with different layouts for each page. And I think that that's probably unnecessary. I think, you know, the graphics, clearly we need those to be properly presented and decided upon, but the actual layout, I don't think we should be having different layouts for every single page. I think if you do a Figma layout, there should be at most 2 templates or 1 template that kind of can cover all cases. And
also, as I was saying, I think that we just need one page that grows. And first of all, we need a finished narrative, and all the concepts and all the storyboards for the illustrations worked before we can have the design or even the front end. We need to have them clearer. So this is why it is important to have the narrative for sooner than later.
yeah. So
And then the CAD can do the storyboards.
yeah, and we'll have to talk to Paco if he wants to do 1 page or click, you know, like that. I'm sure he has some skin in that game.
Yeah. What I'm saying is that it's very important to have the
We gotta
narrative to understand, because what Paco did in the pull request that doesn't fit with the narrative, because the narrative now it's different. It is not going to have 1 photo per paragraph.
Yeah.
So this is why we need a Google Docs that contains everything, also the descriptions of the images or the storyboards of the images, and the parameters and the graphs, at least some charts written in paper and pen of how the chart should look like.
Yeah. I mean, I think we have.
We need that Google Docs.
I think we have it all the way, like, pretty complete, or 100% complete until the exit tribute. So the first, what is that? first half basically is complete.
I still would like to see the
Conviction building.
storyboard and
Yeah, the illustrator
yeah,
piece.
and see how everything fits together.
Cool.
We,
Okay.
And we don't have to do it well at the first time. We can do many iterations, but let's try to make well the first time, so we don't have to throw away the work that we put on it.
Okay.
So steps for the next week. I won't be able to work this week because I am working on another project, and this week is going to be very harsh. I don't know at until what point I will be able to be with you guys. Now after this call, we have a call with Andrew. If anyone wants to join to understand what the cadCAD simulation on conviction voting looks like, I think that it's pretty interesting for the newcomers, because it's something that we checked out the first common simulator calls, but I think that it's an important part of the project. This is what we are trying to do, to bring that simulation into life. So if you want to see that, just we can do that in 10 minutes. And for this week, what do you think that we can do? Finish the narrative. It should be one of the priorities.
Yeah, that's definitely my top priority. And also now I was still waiting for a couple of people to do hourlies. I guess now we can move to action steps for the week. I also need to pay everybody. That's number one on my list. And then number two is finishing the narrative. And I'll put that in there. Does anyone else have action steps they're going to try to take this week?
Just a comment. I just went through the board and separated out the user sessions into another ticket. So I've left cadCAD task queue as an open ticket and moved user sessions into done and merged it in. Yeah, also going to be a bit low on capacity this next week, but can maybe jump in on. Yeah, I have to look through and see.
I think that we can close the cadCAD. I think that we can close the cadCAD issue, the cadCAD queue issue, if we are not going to implement it at the end, because
Cool.
the cadCAD is thread free, thread safe. Sorry.
Well, let's hope. Let's try use your server, Sam, and see that that's actually true. I think it's true. Yeah, and then we can close it.
Yeah, after we test it, right? We're not there yet.
Yeah, let's test it. Let's test it before. And can we ask people from cadCAD just to make sure? Did you do that, Ben? Did you say that you do that? You did that, Ben?
To make sure of
that it's thread safe, except for the matplotlib part, which is not thread safe.
I'd love to. Yeah, I'd love to hear it from them. I haven't actually spoken to them.
I asked them, and Andrew just didn't have the bandwidth, honestly. Well, I didn't go on their Slack because I don't have good access to Slack right now. But I asked somebody to ask them, and Andrew never got back to me, basically. So.
Yeah, I mean, my feeling with the cadCAD simulation is that the only shared resources will be, like, I can't imagine in a multi-threaded environment with separate processes for each cadCAD what they would be sharing between those threads. But I think if it works on SEM's server, I'd be happy to just kind of continue and not distract the cadCAD team.
Yeah, let's solve the problems we know exist. Andrew, I know you have a lot of stuff on your plate, right? Did you have anything specific?
Oh yeah, and yeah. Sorry. Yeah, I know what you mean. I was learning Haskell.
Well, I more mean like you're taking on the entire cadCAD rewrite, basically. And so I don't know if you had a strategy of things that you wanted to attack first on that, or if that was happening in the next call.
Well, actually, ever since yesterday's call with Sam, I felt like this could be simpler. We'll see how that really goes. But before it was like, holy shit. And then now it's kind of like, oh, okay, I can kind of like whip this up in the day or two, something like that. So that's kind of the feeling I get. We'll see what happens after this call.
Okay, very cool. Very cool. And then Nelson, have you had a chance to look at any of the issues in there, or Ben, you were saying that maybe there's some things specifically you think Nelson might be helpful with?
Well, I was just going to say, if Nelson's going to jump back on board, I think the last remaining thing is just to test this last ticket on SEM's server, and then if there's anything that I can help to get you back on board, Nelson, then can do that. Yeah, there's still a fair few backend tickets to be worked through. So
cool. Yeah, I started looking at the Canvas board. I want to, for example, the color is finished, to take time to look at all of them and look at the code and see what's the priority. But yeah, right now I don't have like one thing. I like to investigate.
awesome. From the backend side, when exactly do we make the conversion from using matplotlib to sending? I guess it's when the D3 charts are ready. You know, when do we start sending JSON to the front end for D3? I don't necessarily see a dedicated ticket for that, but
I can add one. Sam,
sorry, my internet is not going so well. Can you repeat the question?
I was just going to say, is there a ticket, and at what stage do we stop using matplotlib and start sending JSON to the front end?
As soon as there is one ticket which is D3 graphs or so, or something like that. I think that it's a big issue because it is a lot of work. There are a lot of different graphs, and D3 is something that people have to learn in order to use it. So I think that it's a big issue.
For sure.
I don't know when we will be able to do that, but it's over there. It's called, I don't know. I don't have it here.
Yeah, I think someone was working on 1 or 2 D3 charts here and there. I can't remember who it was. So I guess as the D3 charts get completed, then we can start thinking about this in future.
And how many D3 charts are there? There's the hatch stuff, the heat maps, and then I guess are these bar graphs going to be D3?
The paragraphs.
The bar graphs, like the hatch tribute, and the exit tribute.
I think that they will be included inside the illustrations.
And then we'll just so it doesn't need D3.
We will see how we do them. Okay. Maybe we use D3 and the illustrations within the illustrations.
Okay, then we'll. I guess that's something that we need to do is just grab the front end team again and go through our narrative and figure out how we want to attack each of the graphs, because in the end that's that's what the backend team needs too, right?
Also, well, the backend is already serving some of the data that the frontend needs to in order to get those graphs. The rest of the things, for example, there is something that we need from cadCAD, which is all the events that are happening to the when cadCAD simulates that, for example, a proposal passes or a user leaves the code or there are new proposals. There is no log in order to understand what is going on in the simulation. And that would be as awesome to have a kind of log and send it back to the front end. So we can, in some way, expose that to the user. And as this, we want much more information that we have right now in form of matplotlibs, but we would like to have in the form of texts and JSONs. As much information as we can get. Maybe we do not need everything, just the information that it's needed in order to do the graphs, and some more information, as I'm saying, about the logs that are happening, so we can represent them in an activity log or something like that.
Yeah,
There is
I think,
no specific issue for that, I
Yeah,
think.
I think I need to let people roll. We need to let people roll out to the next calls, I assume.
The issue that we are talking about is that JavaScript graphs, which in some way needs that backend changes in order to be able to be created. It's not so difficult because all that information is already in place, so the matplotlibs can be done, and we just need to JSONify that information. Okay, I don't think that it's going to be an issue.
Okay, well that's good. I want to make sure to respect people's time on here. We're already a couple minutes over, so thank you guys for coming. And if you need anything, I should be around. I think we're all, we're all busy being quarantined this week and all these crazy projects, but I should be pretty responsive on Telegram if anyone needs to chat. So thank you guys.
thanks,
The,
Cliff.
the guys that want to stay and see the conviction voting simulation with me and Andrew can join us.
Okay, yeah, we'll just do it here. Okay, cool. Well,
Bye, guys.
you're free to go if you need to.
Can you have like a 10-minute break so like we can adjust to the thing?
Yeah, sure.
Yeah. So see you guys back in 10 minutes.
Okay,
Okay.
see you guys.
Cheers.
Bye.
Bye.
Hmm.
Hello, I'm back. Hi, Nelson. I think you're muted. You're muted.
Hello.
Okay. Hi, Sam.
Sorry, I was muted too.
Hey, well, I was muted, but
Hello.
I thought if you press the space bar, it would unmute you just for the time of talking.
Okay. I
Doesn't seem
wanted
to
to
work.
show you the conviction voting simulator, the conviction voting simulation. Were you in the call that we go through it, Nelson?
When was that?
It was one of those in one of the I'm sorry, of the common simulator calls. I don't know if it was the third one or something like that, that we went through the simulation. Probably you were not there.
I don't think so. But let's see.
Yeah. Let's see. Well, it is in the block science. Conviction repo. It's in my screen, right? And we have that conviction cadCAD 3 Jupyter notebook, which is taking the functions from that conviction system logic 3. And what we have here is that we don't need that anymore, because it is when cadCAD needed an extra token in order to be downloaded, but now it is not. You need to participate in the beta program and all that stuff, but you can just erase this part of here. And the thing is that we have that trigger formula here that I explained to Andrew yesterday. You want to me to
I'll explain it. I'll explain it. Then you can see if I got it.
Okay.
It's actually
go
a good
ahead.
exercise. Cool.
Yeah. So okay. So what we talked about yesterday and so far is basically the hatch. The people who want to hatch something, they get together. The money goes in to the hatch, gets split into a collateral pool, which backs the actual value of the tokens, and then a configurable other percentage goes to the funding pool, which will actually, fund activities of this group. And then so this hatch will then use the bonding curve to generate the tokens and figure out how many there should actually be. And once we've gone off, once it's set up, everybody's got their tokens and everybody's got the money sitting around. And then we can start making proposals. And then there's proposals on what to spend money on. And this trigger threshold basically says, at what point this proposal can be said to have passed. So yeah, this that's basically the simplest explanation of it. Like at what point at what threshold can we say that this proposal has enough support and it'll go through.
Okay, and can you go and explain what are the behavior of that function?
Yes. So basically, it depends on the amount of money available in the funding pool.
and the amount of money that the proposal is requesting. So if you don't have much money in the pool, like say 2,000, and you are requesting like 1,000, then this trigger threshold function will make it quite difficult for this proposal to pass through. By that, I mean it says you really need a lot of support. It will say that you really need a lot of support for this proposal to go through.
Yeah, the requested and the funds are goes here, and then we have other variables. Those of them are constants. One is beta, which is set to 0, 2 sometimes. It can be another number. And that beta represents the max amount of money that you can request per proposal. So a proposal that requests 20% of the funds, probably it's not going, well, it is not going to pass never, because it just is infinite. The amount of conviction that you need is infinite. And something that is near beta is also very difficult, because that function tends to infinite when we are near beta. Okay? Because as it is, if we have that share that it's similar to beta, then it's beta minus beta, and it's 0. So something that divides 0 is infinite.
Could
So
you
we want.
Could you explain beta and whole? What I see that
So
it's a
basically,
mathematical
beta means
variable, but what do they mean? Like what? How do
Beta-
you choose the value?
beta is like 20%, right? 0.2 means 20%. So the equation is set up so that if you request, if a proposal requests 20% of the funds from a funding pool, then the equation is set up so that the proposal will need a lot of support to go through.
Yeah,
Okay.
actually, if it's asking 20%, it's going to be impossible. If it's asking for example, 19%, it's going to be very, very hard. That's the idea.
I see. It's by default 20%. But okay.
So we have another constant that makes things easier or more difficult by multiplying the amount of conviction required by a constant. So it is adjustable in a direct, I don't know the word in English, but it's like something that is used to parameterize the function, and it's constant.
So
And then
Rho basically tunes how quickly it becomes impossible, right?
in some way, yes.
Okay.
It doesn't change the way that the Driscoll formula, it just multiplies everything. So it is like moving the Driscoll formula instead of changing its shape.
Yeah.
It just moves it. And we have finally the supply, which is the amount of people who can vote. So for example, when we have 10 tokens that can vote, the conviction is less than the conviction required is less than when we have 1,000. And this is because the conviction that 10 tokens can reach is different than the conviction that but it's proportional. We need that variable here because we want that threshold be proportional to the amount of maximum conviction that that tokens can reach, that the total amount of tokens can reach. I should explain before what is the conviction formula.
Wait a minute. The supply you said again is the total number of tokens ever created, right? That exist.
Yeah, but they can also be burned by the bonding curve. So it is not the total amount that has ever been created. It's the total amount of tokens that there are right now.
Yeah. Okay. Okay. Cool.
I will also explain the conviction formula. Let me see. I am here in the conviction system logic 3, which probably is the way that we can find that. Okay, maybe we. Well, it's an easy formula, but I'm not finding it. We have funding curve equations here. Maybe conviction order. I don't know. No, it's just two ordering proposals. Well, probably it's going to be here, right? Okay, I'm not finding the conviction formula, but we can find it in the conviction key breadth over here on the medium. Let me see if we can find it. We actually need a medium article that explains the conviction formula and all that things, the threshold and all that things, because I don't think that it's here anymore. Okay, so let's go to the code on conviction voting app, and for sure it's here. There is that library that it's made for conviction, and here you can see everything. There is one function that it's used to calculate conviction, another one to calculate, I'm sorry, well, just replicate the conviction formula is over here, which is, I'm sorry guys, this is much easier than, I'm just.
So you wrote this code, right?
Yes, this one, yes.
And the original document that provided these equations is gone?
Yeah, we have, I don't remember. I wrote that code some time ago. Maybe, actually, those functions are pretty good because you can change the way in which you instead of knowing how much conviction you have, you can know how much time you need to reach a certain amount of conviction. Those things are cool, but let me share you another thing. I have a spreadsheet. It's not a spreadsheet. It's a slide This is the one. Probably we should begin from here. This is the conviction formula. The conviction formula is the conviction that you have right now depends on the amount of tokens that are staked right now, plus the amount of tokens that were staked 1 unit of time before, multiplied by an alpha. This means that when you have, for example, when you stake 1,000 tokens, for example, you X is 1,000, and at the beginning, the amount is just 1,000, right? Because we can define that as, well, y0 can be 0. So y1 can be y0 multiplied by alpha plus 1,000. So in the first place, it is 1,000. In the second place, it is 1,000 multiplied by an alpha, which can be 90%. So we only have 900 here plus 1,000. So there is conviction is accumulative, but it have that decay. So it reaches a certain point in which each time that constant here makes the conviction grow less and less until it reaches a saturation point, which is 10,000, which is the 10 times more than the original staked tokens. If it is 0.9. I don't know if it's so clear, but the limit when time tends to infinite of this function is 10. It is x x multiplied by 10.
What is alpha again?
Alpha is a number between 0 and 1, and it's called decay. So it is a way in order to make that the conviction that you accumulate over time to tend to a certain amount. So when you arrive, it will always be a little more, but it is never going to go through 1,000.
10,000.
10,000. In the case that you are only staking 1,000 and alpha is 0.9.
So,
okay.
Okay. Oh, so wait. Sorry. Alpha is it sets the asymptote, but actually no way. I'm pretty sure if I graph this, it's a simple 2x plus y kind of equation. I don't see how this could make the drop off that you see after the end, and then I don't see how this could make the asymptote at all.
I didn't understand. What is? Can you repeat your question?
Okay, so you're saying that x plus alpha and then y t minus 1 is going to give you the shape of the graph from 0 to, let's say, 50, 50, right?
Yeah, until here, yeah. And then when you drop all the tokens that you have to 0, this is the other graph that appears. Because when you have big conviction here, and you have x equal to 0, then the next one you still have a lot of conviction. That is going to be decaying slowly.
Yeah, because you still have x minus 1, y minus 1.
At this point in time, you are dropping all your tokens and probably staking them in another proposal.
Okay. And this 0.9, how do you find it?
Actually, it's configurable, and depending on which is the alpha, the curve behaves different. What it happens when the alpha is low, like 0.5, it is that the conviction doesn't accumulate so quickly. It is very difficult to get conviction. It's like a very, very slow curve. And when we have a very high alpha, the conviction grows so much much faster.
Okay.
Not only faster, but also with more, the amount of conviction is bigger. Okay.
Okay.
So this is the basic formula, and if we work with that a little bit, we obtain that formula here, which is the same one, but this is easier to implement in Solidity. This is the only difference. Also,
how is
yeah, yeah,
how is that the same as that?
I don't know. I didn't do that.
Also, why? Yeah, sorry. Go on.
No, I was just gonna say I'm a little bit the same. Like I need to refresh my math skills. Probably use the plague time to do a math MOOC to understand this formula.
Also, the amount of tokens x is 1,000, right? So y0 should be 1,000, but there the graph says it's 0.
I'm sorry. What formula are you talking about?
It says y0, right? Y0 should start out at 1,000, right?
Here. Yes. Here, y50 actually is 10,000, and for example, y52 is around 9,000, and this is because x is 0, and we are taking the previous one, which is this one, and multiplying it by alpha, which is probably in that case 0.9. So we obtain that at that amount, or this or this, it is only 9,000.
Okay, so in the beginning, I have 1,000 tokens and I stake it on a proposal. So X is within 1,000 and the beginning is 1,000 plus there was nothing before this. So plus alpha times 0 is 0. So that's 1,000 and that would be Y0 or Y1?
Y1, I would guess.
Yeah. This is Y1 and this is Y0. And the next one, this is Y1 and this is Y2. And the next one, this is Y2 and this is Y3. Actually, this looks like this. And yeah, the conviction is accumulating. So this is 1,000, this is 1,900, I think, and it goes accumulating like this. Each time there is less and less that is increasing, until there is a point that the increasing is not so much, until the person who were staking decides to withdraw all the tokens, and now the decay begins. until 100. And why this is the same than this one? It is because this one is the same than this one, because if you sum up all those, for example, if you put this one inside here and then put this one inside here and do that in a way that is a series, you obtain that it's a summatory of alpha elevated to t. And you can extract x, and also you have that first number here that I actually don't understand why it happens. But if you believe that this thing is the same than this thing, then you can use another mathematical tool in order to transform this thing into this thing.
Yeah.
Okay, maybe.
Don't ask me why. I'm sorry, I don't know. I don't know. But if
But
you
yeah, if you put like y1, if you put x plus alpha y0 into alpha times y1, then that starts to sound probable.
There is a document over there which is in a HackMD or F Paris. I don't know if we are going to. Okay, this is a document that explains more or less what is going on, but actually it goes directly, like computing a direct function, and it is like combining those three steps, which equals blah blah, summing summation identities, blah blah. Maybe summation identities is, I don't know, maybe this is what you need to look for in order to understand what's going on. This is the, I can share it with you. I am sharing it here in the chat. And well, we have some more information here, but I don't know if it's so useful right now. The most interesting thing is that if you have different people who is staking, the overall conviction, summing each of the, calculating the conviction from the amount of tokens that are staked, it is the same thing as summing the convictions. So there are two lines here. One is green and another one is of that color, but they are overlaid. So the green line is this one too. Okay. This line and this line are the same when X is the conviction. And you can see how, depending on which alpha you have different, different shapes. When alpha is bigger, the conviction grows very differently, much slower. And when alpha is very, very sharp, it is like it grows in just one moment and then it stays equal. Does it have sense?
Cool. Yeah, kind of.
Well, I hope that it is easier to understand now with these formulas. This is the threshold. This is the amount of, not the share of funds. If we go, for example, 10% of the funds, it is very easy to get them, and we went for a 20% of the funds. It's impossible. Of course, if you zoom this formula, it is even a very, it is still much easier to go for that amount than going for that amount.
Yeah. We saw that before, right?
Actually, we didn't show it, but we explained that. This is.
I have a noob question related to what you guys were saying just before. Like, if you want to use more than 20% of the fund, the probability that you reach the threshold goes to infinite somehow. But what if there's a consensus where it's like, okay, we all want to do this? See what I mean?
The previous consensus is that we cannot spend in one proposal more than that. Of course, there can be other ways. For example, direct voting, but maybe we want to protect ourselves to make dummy decisions, like spending all the money on just one important thing. And well, it's a kind of Ulysses Pact, in which you know the Ulysses story. He said to their people, please, I want to listen the sirens. Is it called sirens?
Yeah, I mean, I don't know if they call it sirens in English, but yeah, I get what you mean. Sound the horn or something, like sound the alarm.
Yeah. The thing is that now we want to prevent to spend all the funds that there are in the DAO in something that seems urgent, but at the same time it's going to kill the DAO. We don't want to spend more than 20% of the funds in just one proposal.
The other piece that I want to add is conviction voting doesn't have to be the only governance module. You can have a regular one person, or token weighted vote that has power to do random things. But if you want to have this really easy, no conversation, signal aggregation voting system, you don't want to be able to spend everything in one fell swoop. You want to have this be dished out.
Cool. I think it might be important to explain in which case conviction voting is useful and in which case it is not. For later on, but I guess that's a long-term conversation.
I think it's pretty simple. It's useful when you're spending funds over a lot of projects.
It's useful when you want to prevent people from hopping around, and you also want to conviction voting, the main purpose of conviction voting is two things. One, to allow to reduce the influence of people who have a lot of tokens, and two, to prevent to discourage people from hopping around with their votes and quickly changing things last minute. So that's basically it.
Yeah.
Yeah, it's kind of nice because you can see, oh, this one looks like it's going to pass. That one looks like it's going to pass. Oh, this one is losing value. And you have this real-time, slow signal aggregation as opposed to, well, let's see what happens in 2 weeks. Oh man, big whale came at the last minute, changed the vote,
It's really it's nice because it gives incentives of long-term planning, long-term thinking.
And it mitigates plutocracy just a little bit. right? Because if someone doesn't have a lot of tokens, but they're very determined, they can have as much vote as someone who has 20 extra tokens, depending on how the max conviction is.
Okay, so we can go through the simulation now. We have that formula here. Those are how that formula behaves depending on the funds requested and the total supply. And the color represents how hard it is to ask for funding when token supply is high or the share of funds that we are requesting is high. So the amount of conviction that we need, or the amount of also depending on alpha, the share of the conviction required, it's also to be very different depending on the alpha.
Could you also explain again why it depends on the token supply?
It depends on the token supply because the token supply is in the formula. And the thing is that if we have 100 tokens in total that vote, the maximum amount of conviction that they can reach is going to be 1,000. Okay, because the limit of that formula, it depends on alpha. It depends on, if it's 0.9, I have that in the code here. The maximum amount of, let me check that. Current conviction, calculate conviction, get current conviction by entity, calculate conviction, get conviction history. 1 sec. Mining conviction trend. Get max conviction. The max conviction is just the amount of tokens divided by 1 less alpha, because this is the limit of that formula. That formula, the limit when t tends to infinite is x divided by 1 less alpha. And the thing is that because of that, when alpha is 0.9, this means that the limit is 10 multiplied by x. If alpha is, for example, 0.99, the maximum conviction is 100x. So depending on alpha, the maximum conviction is going to be different. And then if it's different, the threshold also should be different. And this is why the threshold have that supply in its formula, and it is proportional to the amount of conviction that the current amount of tokens can get. Does it make more sense now?
Yes. So basically, if you have this many tokens, they can only give you this much conviction at most. So the point at which a proposal can pass should also scale to match how much conviction could eventually be put into this proposal.
Yep. And also, this is why we also can see that alpha affects that number, because with more alpha, with a higher alpha, it is easier to ask for something.
And I guess, just the fact that you have 1,000 tokens and you want to use 100 tokens is not the same as if you have 1,000,000 tokens if you want to use 100.
Yeah, I think so. I actually don't. I actually don't get everything yet, but yes, I think so. You can go following the formulas and see and take your own insights from them.
Mm.
The simulation continues, and what we get, we call two functions. One is initialize network, and the other one is initialize bonding curve. And they are in the conviction voting logic 3. And what they do is to use a library in order to generate random participants and random proposals. Those participants and proposals are going to be stored in that network here. And also there are some random initial funds. Depending on those funds, we have also that initial supply here. So we have a supply that it's being a supply of tokens that is being generated, and an initial funds that hatchers wants to add into the system. And that total requested, I don't know what it means. And once we have that network of participants and proposals, we initialize the bonding curve. And this initialization is done by the parameters that we got here. And what we get is the initial reserve, which is the amount of money that goes inside the bonding curve, and an initial price, which is not the same as the price that those people, the hatchers, have obtained the tokens. It is the initial price of the bonding curve. So when we have that initial supply, which that people already have obtained some tokens before the bonding curve, when we initialize the bonding curve, we initialize that with one price that is not zero. It is already because the token has already have an initial supply. And well, then there is that invariant that is very important for the augmented bonding curve. It must be always the same. The invariant formula can be found somewhere else, but it's related with the reserve and with the supply, I think. The supply and the reserve, and there is one formula that it also derived by this constant here kappa. That must be always the same. Now we will see more graphs in which we see how it works.
Wait a minute. Yes, you mentioned this yesterday too, but I forgot again. So when all the hatchers come together, they to split their funds into X amount of tokens and Y amount of funds. They just choose any particular random point on the bonding curve, or how do you know where on the bonding curve to set the price at for the hatch?
It is because of that initial supply. We here we do a kind of treat with them, like, okay, we are going to issue funds at an initial price, a sale price of 0.1 dice per token. This is here, okay? This is the well, it can have many names, but this is the price in which people obtains the tokens in the hatch. And when we initialize that network, we obtain that initial funds that those guys are putting, and those initial funds should be distributed into the two pools, the reserve and the funding pool. I don't know if it is been doing here or not. I don't know. If not, we have to add it. It will be easy. It's just to set a new parameter and divide those initial funds into pools. And also, because of that price and that initial fund, we know how much tokens we are going to give them. Because if they give us 1 million dice, we have to give them 10 million dice because of that price. And once we have that initial supply here, this is the initial supply of the banding curve.
Sam, could you repeat that? What if they give us 1 million die, they get 10 million die or 10 million tokens?
Yeah, sorry, the 10 million tokens.
Yeah,
They
I was
get...
like, thank you. I bugged out for a second. Thank you.
But okay, they put in 1 million die, they get 10 million tokens, but actually, let's say only a percentage of that 1 million die is actually backing those 10 million tokens, right? So the price
Yes.
is not actually 0.1.
Yes, and at the same time, probably the price is going to be much higher because of the shape of the bonding curve. If in this example here, we have an initial supply of 30 million tokens, but it's under collateralized. It's just 1.9 million dice, when it should be 3 million dice. It's just that 1.1, I think. Yeah, 1.1 million dice went to the funding pool. And yeah, the rest is collateralizing this bonding curve. And also the price is much higher than when people put their money inside. The price is 0.3.
Yeah, so the idea is that people know that their token is under collateralized, right? Just like Jeff Bezos knows he doesn't actually have $132 billion or whatever. If he sold all of his Amazon stock today, it wouldn't be worth that much. But if he sells one stock, it's worth that. And this is the same thing here. I generally call it the market cap illusion. The price of the token is determined by the bonding curve, but there's this thing called slippage. If you buy a lot of the tokens, the total price that you get will be less than, or will be more than. If you buy a lot of tokens, you will move the price up. So your average price will actually be higher than what the price says now. And the same if you sell a lot of tokens. If you sell a lot of tokens, the average price for each token will be lower than the current price. So it's kind of this weird game where there is only 1.9 million DAI collateralizing these tokens, but the token price is 30 cents right now for one token, and there's 30 million tokens. So that means there's a $9 million market cap collateralized by 1.9 million DAI. But if everyone sold their tokens right now, it wouldn't be worth $9 million. It'd be worth 1.9 million DAI, right? So it's kind of this weird thing. What's funny is it's also the case in the normal world, right? For every stock and every financial asset that ever exists, it's just not transparent.
I actually had lots of conversations lately talking about this in the context of people saying, oh, Jeff Bezos has 200 billion, or this guy has like 20 million. It's like, no, not exactly. It's worth that, but if they actually sold everything they had, they would probably end up with, instead of 200 billion, I don't know, 50, or it's still a lot, but that's not how it works. And I think most people, it took me a while to understand that too, but it's not necessarily common to of the normal human brain walking on the street to picture that. But that's how the world works.
Yeah, I'm having trouble internalizing that. I mean, it made sense yesterday, and today I forgot it.
Okay, let's continue.
Mm.
So once we have the bonding curve initialized, we get what the proposals and participants that initialized network has done. Remember that they are random. And also we have those proposals. There are some participants that support them. The participants between them influence each other, and also the proposals has conflict with each other. We have that graphs, that graph of proposals and participants, and that edges that represents support, influence, and conflict. So when we depict that, we see that graph of participants and their supports, their influence with each other, and those proposals and their conflicts with each other. Okay? We also have for each edge the affinity, the conviction, the tokens, blah, blah. So we can still depict
About
that.
the influence of these participants. This is something that's not really part of the conviction voting thing, right? It's just something that you set up outside
we
of.
start them randomly, and we are going to use that in order to simulate what is going to happen to those proposals. It is very random. It is like we can think that those participants are going to behave in that way. We can also see how the participants and the proposals, what is the shape of the network in histograms. For example, we see that 17 participants or so have not so much tokens, and there are 2 or so, or probably 1, that have more than 50,000 tokens. So we see in that way how much tokens have the participants. Like most of the participants don't have so much tokens. Then we have a lot of participants that have around 5,000 and 25,000. This is the most amount of participants. And then we have some participants that have a lot more. And this is important in order to make to understand what is going on. Maybe that participant that has more than 50,000 wants something, and the rest doesn't want it. What is going to happen? Also, the proposal there are 2 proposals that request around 50,000, and there is one proposal that is asking around 35,000. As you can see, 2 proposals that are requesting that amount, 1 proposal that is requesting that amount. There are only 3 proposals at the beginning. And finally, but not least, this is a graph that represents the support that one participant has over one proposal. So for example, participant 28 doesn't like, I think that doesn't like, because it's black, doesn't like the proposal 62. Well, actually it's proposal 1. but it's not well represented. So as you can see, the red represents that they like it. Well, actually, no. The white represents that they like it. The black represents that they don't like it. And this is also going to shape how the simulation is going to work, and it's completely aleatory. Okay? We set up the simulation. What we need is to set up some parameters and some policies. So the policies are, for example, how we are going to, which is the initial sentiment of each participant, how it is going to be, actually no, actually the initial conditions or parameters. Let me see. The initial conditions, for example, well, we have that sentiment decay. Sentiment is how much engaged are a participant in the community, and over time, this sentiment is going to decay, right? So we have this parameter here. We have many other parameters, and what we are going to do is to set up some policies, like let's make decay. Let's when we complete when we fund a proposal, we are going to make the sentiment grow, and when the time passes, we are going to make the sentiment shrink, and all of that is here in these policies. Also, what the participants are going to do, all those things. It is not so complete. It is like naive decisions, and in the future we can make those decisions better, but it's enough to simulate what could happen with all that.
How is sentiment different from conviction?
Sentiment conviction is something that it's part of the system, and sentiment is what sentiment represents. It is not. It is just a parameter that we use for the simulation. It's not part of the conviction voting, anything of that. Okay, it's just a variable that we use to decide what the participant is going to do.
Yeah.
So
Sentiment
participant
says how much they like the commons. If their sentiment is low, it's because the commons isn't doing anything. They kind of lost faith. My sentiment in Molekdal right now is kind of low, but my sentiment in Metacartel right now is pretty high, and that's just me personally. And this will influence their actions in the simulation. So it's kind of like there's two things going on. There's the system, and then there's the actors, the agents that are going to run and play with this system. And we can run a simulation 10 million times with the agents and some randomness and see what happens.
Okay, that makes sense.
And when a participant doesn't have so much faith on the project, normally they leave the commons, and this is why when we depict the funds in the funding pool, we see how they grow over time, because this means that participants are leaving. In that case, we are depicting how has it gone in commons that alpha was 0.5 and no proposal has passed. So the general sentiment of all participants has decayed, and probably most of them has the commons. but we have a lot of funds now. In another case, in which we have alpha 08, 1, 2, 3 proposals has passed, but still people is leaving. Because, for example, in that case, the proposal is cool, a proposal passing makes people feel happy, but in another way, if you see that, you see how participants are very engaged because they are not leaving over time. It's in a case in which alpha 09 makes the participants pass their proposals very quick. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 proposals passed, and it's a lot of proposals. If you remember, we only had 3 at the beginning, and they came up with a lot of new proposals. And their sentiment is very high because we don't see so much people leaving, and at the same time, it's a problem because we don't have more funds in the pool in order to fund new proposals. And well, if we take one of them, for example, the second one, which is the one that no, we are taking the third one, I think. We're taking this one. We go through that and we can see some tables on the fund supply reserve and spot price over time. And those tables can be transformed into that graph. And that graph represents how the price of the token has been increasing over time, how the supply has also been increasing, because when the price increases, also the supply increases, and the reserve also has been increasing, because when the supply increases, the reserve increases. But the funds are actually not increasing at all. We don't see that very well, but they are decreasing a little bit. And we see that the observed data and the invariant are pretty close, because this is how it should go, because that invariant is very important and it's not there for other systems. It is what guarantees that the reserve holds the money that your token is under collateralized, but at least the amount of you are going to receive some part of it. Some way that there is that formula that is invariant, and at least you are going to
invariant guarantees that at least some fraction of your token is collateralized.
Yeah, I think so. Is it like this, Griff?
Yeah, I mean, basically the invariant is, you could think of it as like, it is the price curve. It is the law of gravity. It is the law of the system. It cannot be changed. So there's a ratio between the token supply and the token reserve, the amount of funds in the reserve. And that ratio equals some constant. And that's determined in advance. And that would say that if there is one token, the price will always be whatever, 1 penny, right? And for the 20th token that's created, you go to that invariant equation and you say, hey, what's the price? And then you can derive it from the ratio between the supply and demand, or between the supply and reserve. So because we don't have any kind of weird mechanism like Aragon does with the tap, because we always have a controlled reserve, the supply, the price of every token is predetermined. So if you're buying the 4 millionth token, the price was known when the token contract was launched. And every token will always have a price.
Okay. What we see after the simulation is that the number of participants and the number of proposals have increased. And we see here how they relate with each other. But the important thing is that they have increased.
So the system basically inserts new participants like randomly or what?
In some way randomly, but
You mean like, okay, so if overall sentiment in the organization increases, then new
Yeah.
participants will be added to the network.
Exactly, this is the way. And then there are some more graphs over here that I didn't went through. But if you want to check them out, you just have to understand. I mean, this is the code. You can go through it like it represents the candidate count, active count, completed count, kid count, and islet count. So you can go through the code looking for those variables and see what they represent. Or for example, in that case, it's candidate funds, active funds, completed funds. In this case, we should go through that share of fund requested all, which I think it's a function. I'm not sure. And well, you can go through those things.
Yeah. Okay. Cool. Yeah, that's.
I'm not sure what they represent. But you can go through them and see if you can understand them. And if you understand them, then you can explain it to me.
Okay.
By the way, we are not going to use those things in the final common simulator. It's just for fun. If you want to understand them, it's just for fun, and it's good because it makes us understand better what those things are. But probably what we are going to show at the end is the new participants graph and that local economy graph and what has been going on, like number of proposals that have passed, number of funds that there are in the funding pool, this kind of things. Probably we are not going with those weird graphs, but yeah, that's everything I wanted to show you.
Awesome.
That's cool. Thank you very much, Sam.
Thanks. That was a good refresher.
And yeah, if of course the code over here is a little bit clunky because it doesn't follow the object-oriented programming, and it may be improved in ways like documenting, or I don't know how actually, because it's code that it's difficult to understand, and even if we explain it very well, it's going to be still difficult. Maybe separating the important parts in some files and other auxiliary parts in another files could help. I'm not sure. If you, Andrew, are refactoring it, it's fine. And Nelson, if you are going to go through the backend part, it's also fine to you to take a look at it, because we are using that code
Yeah.
in order to at least the final part, which is cadCAD, but also we are using that network, and this network is the one that appears in the, then we make it in this tree.
Mm.
So we are basically following up this Jupyter notebook in order to create the simulation. And yeah, that's all. I will not be super active this week, but next week we can hop again into that call and see how we are, and how we can advance. I hope that you can do a lot of stuff this week. And if you have doubts, just tell me. I will try to respond them, but I cannot assure that. And in next week we see again.
Awesome.
Okay, guys.
Awesome.
Yeah.
Thank you very much.
Thanks, Sam.
Yeah.
All right.
And I guess
no problem, and thank you so much for being here and keep it together.
yeah.
Bye, guys.
Ciao.
Bye bye.
Ciao, everyone.